Hello, my name is Timothy Barnard, and my student number is C13720705, and I'm doing the Linda's Lighting database project. Firstly, I'd like to go over the ERD data modeler design, and then I'll go into the Oracle and show you the commands going in. So in the ERD data modeler design, we have a few classes, objects, as you can see them here: customer design, employee, department, customer payment, stock, and supplier. The relationship between customer and customer design is a non-identifying one-to-many relationship where the customer design has its own primary key, so it doesn't need the primary key from another parent table. That's why it's a non-identifying, and it's one-to-many because a customer can have many designs. Same with employee, it's a non-identifying relationship as it has its own primary key, and it's also one-to-many as each employee can work on many designs. Same with department, each department can have many employees working for them. The lightning spec, each design can have quite a few products on the design. And here we have created a weak entity, which is like an array of objects, because we are having more than one product using on the design, and the way to show this in a database is to have a separate table created, and then this displays all products used in that design. And then same thing we have another one, weak entity, like I said before, and then we have supplier with a one-to-many stock order, so supplier can have many orders, and then the stock item ID. The stock, which is just whatever the the company has in stock. Okay, so now I'll go over to the data modeler, and I'll quickly describe what's going on here. So at the beginning, we have to create the tables, which we got from the data modeler. We did the forward engineer, which does all the drop tables at the beginning first. So at the bottom we have all the parent tables, and at the top we'd have all the child tables, because if we did it the other way around, we'd have errors because of the foreign keys still being used or needed. So I'll quickly scroll down and I'll go over some tables and go over the data types that we're using. So for example, the supplier, the ID that's using is a number with 6 digits. Also not null, which means there has to be something going in. Supplier name, which is varchar2 with 20 characters, and just the phone number with the varchar2, just in case they wanted a space, as I have in my design. In the stock order, same thing too, but problem with the difference is we have a foreign key in here, so supplier ID, supplier foreign key, which is taken from the supplier table with the field name supplier ID, which, as I said before, created up here. So we have the stock table, which just has all the products being that the company has its own primary key. Stock order underscore stock. This has 2 primary keys. Two foreign keys that are taken from 2 primary keys from all the tables, which means that is a weak entity. And then we have customer, which has its own primary key, no foreign keys, first name, last name, address. Department, same thing, just the name and the ID. And then as we work way down, we have employee, same thing again, apart from that has a department ID, foreign key. Customer design has 2 foreign keys, which is taken from the customer ID and the employee ID. And then we have a lightning spec, and the lightning spec stock, which I said before, which is the weak entity, and then the customer payments, and then commit. So if we run this, we should get no errors down the bottom. So as you can see, they have been dropped, and then as you work your way down, they start to be created. So we'll clear that script. Now let's go into the statements to insert them. The data populate the table. So if we run this, it should all be hopefully be fine. But I'll quickly go over 1 or 2 of them. So supplier, as I said before, has an ID, surname, and number. So we just put some data in. So just 112 has to be unique, so each one of these can be different. And then we have just the supplier names and the phone number, like I said before, the dash if you require. So it's a varchar instead of just a number. And then we have the stock item ID, which has the supplier ID's number. So this would have to be the same as this column, as this is the foreign key for that primary table, for that primary key, sorry. And the same thing for stock. This has digits, 1.00, which is the price. And like I said before, they can go up to 7. Or maybe I didn't say that before, but the data type for a price is a number 7, 2. I should be able to show you this quickly. In the customer design here, it's number 7, 2 right here. So it's a null, which means that it doesn't have to be filled, just in case the customer hasn't paid yet. So, and these are the rest of my tables. They're just populating data, so they should all run in with no problems at all. Now, as I said before, is the foreign key problems that some people do have is that by putting in the parent table first, and then after that you do the child tables, that's where you should get the statements done correct. So all the data should be populated. So we can run a few of my standard select statements, which shows you, as you can see here, some names, stock, sorry, up here, to run it. As you can see here, some uplighters, double bulbs, etc. And we can do a customer payment underscore stock, which is the weak entity, and it'll have just 2 items, just the stock ID. It's very useless on its own, but it will be used when you do the joins and any joins later. So first statement we're going to do is select upper customer name in init caps surname. So all this does is it selects any customer, so from the customer table where the customer ID is greater than 5, it's going to uppercase the first names and uppercase the first characters. So if we quickly do a select statement of the customer, you can see here that they all are capitals. So this one here would not work. Well, it doesn't really make a difference. So if I can change this quickly to lower, and then if I run that command, as you can see here, all the names are small, capital letters of first letter of them are capital, and you can see there's only 5 because I'm only selecting any ID less than 5. Sorry, greater than 5, greater than 5. So then the next function is called an aggregate function. I'm just doing the simple select count from stock, so it tells me how many items are in stock. So we have here 10 items, which means there are 10 rows in the stock item. I can do anything at all. I can do select star from customer. I can run that, and that should give me back 10 too, because I only have 10 customers gone in here. Now the next one is an inner join on 2 tables, and we are taking the customer design, the first name and return date from the customer design table and the customer table, where the customer ID is equal to the same customer ID. So if I run this, it'll make more sense when I run it. So we are taking the customer design ID, so it's the table where each customer gets their own table in a way to have it filled with their own design. And we have customer first name and then return date for them to pay, which is very useful for companies to run that script. The next one is an inner join on 3 tables. I'll quickly run it. So this is an inner join, which basically means that the columns that we're taking from 3 tables have to have the same name. Sorry, not the same name, the same data type, and probably be this, and also the same name within 2 tables. So here we are selecting the first name, return date, and the customer price that they have to pay that's due to them. As you can see, the first name, sorry, the name, return date, and the price you have to pay. So we do a select statement from the customer. So we're returning these 3 columns with from customer, customer design, and customer payment from them 3 tables, joining on the IDs and the customer design IDs in the other 2 tables. Now the select left outer join, as you can see, being populated, which is just the employee name and the department name. So it's from 2 tables, and it's left outer join would actually show null values down this side, but just the way I did it and just the way they're populated actually doesn't display. But what it will do is it will bring back everything from the left table, and will join everything that I set it to join on the right hand side of the table here, and if there's no joins it will display null, unlike the inner joins. Same thing too with the right outer join, but here I've also selected data that between type that they actually don't come back null. So what this is doing is it's selecting everything from the right hand, from the column on the right and displaying everything on the left. That if they don't have anything corresponding to it, it will display null. But like I said before, the way I did it was it displays everything. It doesn't actually has any null in stock. So the next one here is an update. So what I'm doing here is update the stock, set this a certain price to where the stock ID greater than 7 is going to be $20 instead of 20 euros. So if I do a quick statement before, as you can see, greater than 7, so it's them 3 at the bottom, they will be all 20, hopefully. So runs, no problems, as it says here. Like I said, the bottom 3 rows will be different. And now if I run the script, 1, 2, 3, or change the 20 euros. Now my next statement, which is I'm adding a column to the table. So if I run this, which has also a default value for n, so if I alter the customer payment table, what this does here is adds a new row. So I can actually do, if you quickly do this here, so I can do a select start from customer payment. Hopefully that is correctly spelt. So if I run this now, we should get a new table over here, paycheck n new, which has n in there. Now the next statement, which is a just an update statement. So what I'm doing is anything greater than $100, the table will be changed to yes. Just a simple statement. So you can see here, anything greater than 100 will be changed. Greater than 100, so that one is the only one that actually doesn't change, just because of the way the data is built. This is a constraint. What this does, it makes sure that whatever data is going in has to be either a y or an n. So for example, if I do this statement up here, like I said with the yes, so if I type in yes, example, and I do greater than 300, if I run that command, what happen is I get errors because I'm not sticking to the rule of y or n. So now if I run the script, I should get no errors because I'm sticking to the y or n check-in. As you can see down the very bottom, 3 rows created. Okay, so that's the constraint added. Now the next 2 things to do is to drop the constraint. So first thing we do is to drop this constraint before we drop the column, because it's connected to it. So you drop the constraint. So now if I run this command, the yes up here, I should get only 1 table entered. No. Oh, that's just the constraint, sorry. So now I can also now drop the table. So you can see down here, the table is the table has been dropped. So now if I do a select start from customer payment, as you can see here, it has been disappeared. So that is my project. Hopefully you enjoyed it, and thank you.